Hi everyone, this is Al from Scapeit. Today we are going to do another video. We're going to look at some Unity specific code that we can use to make the user interface of Unity look a little bit better. In particular, when we have multiple elements on screen, like here, like this is a dialog box for a character in the game. When we have both the descriptive text and then we have the options, how can we make them fit together a little bit better? I haven't had this before in my game, so if you played the earlier demos of the game looked a little bit more like this. You would have the description up here, and then no matter the size of the description, the options would always be down here. And that doesn't really look very good. It leaves a lot of empty negative space in between, and it's a very poor use of screen space. So we're going to try and do something that changes the position of the options dynamically based on the size of the description box. This isn't as straightforward as you would think in Unity, or to put it in another way, there is probably a built-in way to do it in Unity. But I'm not really a big Unity fan, to be honest. I really enjoy the cross-compiler and the way there are some work processes that are easier in Unity. But all in all, I think you have to jump through a lot of hoops to make a proper 2D game in Unity. Unity is basically a 3D engine, so making a 2D game is not really what Unity is built for. But nonetheless, this problem has an easy solution, and we are going to look into it. This is the anatomy of a scene interface, the way we just saw a second ago. It has the descriptive text up here. It will overflow vertically and fill whatever space it needs. And then the buttons will be down here, the options. And we want to be able to move the options up to match the size of the descriptive text so that it constantly comes right up under the descriptive text. The algorithm to do so is fairly simple. We just create a list and then we insert all of these elements, and then we start with the first element. We see how high it is in terms of the text that is in the element, that's currently in the element, and then we take that height and then we move the next element in the list up to that height and so forth, so that everyone kind of bunches up together on the top of the screen. If we look a little bit closer on one of these objects, for instance, let's take the description box here. We see that it has a component called a rect transform. This basically decides the decision, or this contains all the positional data of the object on the screen. So we can see if we move this, if we change the X position, we also move the object on the screen. So this is the component that we are going to access, and these are some of the variables we have to change to move components in relation to each other. Going to the code editor, we are going to use the GUI control object, which is the object that interfaces the Skald engine with the GUI elements of Unity's engine. And we are going to make a function here called adjust vertical position. And the function is going to take as its parameter a list of text objects, and the text objects in this context are objects like this text box or the text boxes that are on these buttons. And then it is going to adjust their position on the screen so that they end up nicely vertically aligned, meaning that where one object ends, the other one will begin, and so forth. And it will sort of compress the layout a little bit. Above this function, I've already cheated a little bit and made a function specifically to adjust the buttons in relation to the major text field on screen. So to adjust these buttons in relation to whatever text is in this field. And it's very simple. It just creates a linked list called the text list, and then it adds first the description object, which is the text box here. And then it takes all of the buttons. They are being stored in a list called button objects. It takes that list and then it adds each button from that list to the text list. Specifically, it doesn't add the entire button object, but it adds the text component of the button, because that's really what we are going to refer to when we do the work. And what it does then is that it takes the list it has created of all these text objects. Remember that these text objects, they contain rect transforms like this, because they have a position on the screen. And then it takes that list and it passes it to the adjust vertical position function. And that is what we are going to create down here. The adjust buttons function, and thus also the adjust vertical position function, is called every frame, because as you might have seen with the Skald engine, the text crawls across the screen. So to adjust it dynamically, it's called every frame, at least for now. We will see it maybe change that a little bit later, but that's how it's going to be for now. So the way we are going to implement this is that we are going to take the first object in the text list and have that serve as an anchor. And then we are going to iterate through all of the rest of the objects and then adjust them in relation to the anchor. So we're going to start by adding a variable called current position, and we are going to refer to the first object in the text list. So we refer to the first object on the list, and then we refer to the transform of that object, which is this component here that contains all the positional data. And then the local position, which is, it sort of translates the positional data into x and y coordinates in relation to the screen resolution, so to speak. And then we are going to refer to the y component of the local position, because the local position is a three-dimensional vector, and it has an x, a y, and a z coordinate, but we're going to refer to the y coordinate because we are setting the vertical alignment. So what we have gotten so far is we have taken the first object in the list. In this case, that will be the text box, and we have that as the current position. But if we didn't add anything more, then the current position would be here. It would be at the start of this object. And then the following object would overlap with the text itself. And that's not what we want. We want to take the start of the object, and then we want to pad that with the size of the text block. And then we want to start adding buttons underneath it. So what we are going to do is that we are going to take the y position and then actually subtract the text list. We are going to subtract because I said add, because in my head we are adding to the y position, but y of 0 is here, so we have to subtract to move down on the screen. The y axis increases as we get higher on the screen. So in fact, we have to take the y position and then subtract the size of the text, and then we use something built into all text objects in Unity called preferred height. This is really helpful because that's basically, it takes the text added, the size of the font, and the width of the text box, and then it tells me what will be the height of the text once it's printed on the screen. And since we update this continually, we will always get the correct preferred height in terms of what text is inside it. So that will be the starting position. It will be the position at the end of the text box. Now we take all of the remaining members or objects in the text list, and then we set their position in relation to the current position, and we also update the current position in relation to the size of the objects in the list. That was a lot of words. It probably didn't make sense to you, but it will. So now we use a for loop, not a for each loop, because we have to skip the first object in this list. So that's why we use a for loop now, not a for each. And we set the I variable to 1 because we want to start on the second object in the list. And as long as I is smaller than text list.count, we will increment I. Okay. And since we are starting on I of 1, we should probably also add just a small little safety precaution up here to see that if the text list count is smaller than 1, smaller than or equal to 1, there is no use in performing the rest of the algorithm, because otherwise we could potentially end up with a bug, an error here, because we would try to since we are starting on the second object in the list, if there is no second object, then we would get an error, and we don't want that, because it's quite plausible that we pass this function a list with only one member. But in that case, it's not necessarily an error. We just want it to gracefully stop doing what it's doing and continue with something else. So that's why we have this there to short circuit it in that case. Now, what we do in Unity is that we have to take the object that we are currently on, and then we have to take its position, modify it, and then update the current position. But we can't really do, we could do intuitively, we could have done something like this. But it doesn't allow us to do that. We have to instead pull out the local position into a new vector object, and then change the vector object, and then stuff it back into the object that we are moving the position of. So we make a vector 2 because we just need the x and y component. It doesn't have to be a vector 3. Vector 3. Then we refer to the text list object that we are currently iterating over. We get its transform, and then the local local position, capital P. Let's try again. That should work. Yeah. So now we have the vector of the local position. It has all the position. This vector contains all of the two-dimensional positional data from the object. So at this point, we will be, if this is the first iteration in this loop, we would now be referring to this object, the first of the options underneath the text box. This was the very first object. So this is text list 0, and this would be text list 1 in the list. We now pull the positional data from that object, and then we take that positional data, and then we set the y position to the current position variable, meaning that we take this object and then we move it up right up until it touches this object. And then we take the vector, basically just take this and then we stuff the vector back in there, like so. And we have now updated this position. And now, since we're going to do that with all of the members in the list, we also now have to update the current position so that we don't just overlap them. So we now take the current position, and since we are basically moving downwards, we have to subtract. So we subtract the current position by referring to this. And since this is a Unity text object, it has, like we saw here, a preferred height variable, meaning the height of the object as Unity draws it on the screen. So we just take preferred height here, like so, and that should pretty much be it. So let's save and see if it works. As you can see here, it works pretty well. We have the text here, and there is no huge field of negative space. Instead, we have them snugly placed closer to each other. I think if I was going to add something, it would be just a small amount of padding between this text and the options. So let's do that now. I don't necessarily want to add padding, I think, between all of the options as well. Let's keep them together a little bit, but just between the first entry in the list and the second one. So meaning between the text field and the buttons below. Let's say let's instead do this, come to think of it. Like so, let's say 4 pixels, I think that should be good. Save, and we test it again. Okay, now we see that there is a slight padding between the text box and the buttons below, and that's pretty much exactly what we wanted. So I think that's it for now. I'm pretty happy with this. I would be more than happy to put the code up on GitHub if any of you would like to use it for anything. If you have any questions, just feel free to leave a comment, like the video if you do, and please check out the Skald devlog as well. The link will be at the end of this video. Okay, have a great day. Bye bye.